Hi guys, good morning. In this lesson, you will learn some theory about shaders in Godot, and after that, you will create a sample shader. Let's get started. A shader is a program that is designed to run in the GPU and alters the way that objects appear on the screen. Shaders are used extensively in both 2D and 3D development to create a variety of visual effects. They are called shaders because they were originally used for shading and lighting effects, but today they are used for any number of visual effects. Because they run in the GPU in parallel, they are very fast, but also come with some restrictions. In Godot 3.0, shaders are run in a language very similar to GLSL ES 3.0. This language is known as Godot Shading Language. If you are familiar with C, you will find the syntax very similar. Shaders in Godot come in three types: Spatial for 3D rendering, Canvas Item for 2D, and Particles for rendering particle effects. The first line of your shader must declare which of these types you are writing. After determining the type of shader, you have another three choices of what render phase you want to affect: fragment, vertex, or light. You can include one or all of these phases. Processor functions. The processor function fragment is used to set the color of every affected pixel. The processor function vertex is used to modify the vertices of a shape or mesh, and thus are typically used more in 3D applications. The processor function light is used to alter the way light is processed for an object. After choosing the type of your shader, you will then write a code that will be run simultaneously on every affected item. This is where the real power of shaders come from. For example, when using the processor function fragment, the code inside is run on every pixel of the object at the same time. This is a very different process than what you might be used to using a traditional language, where you would loop over each pixel one at a time. That kind of sequential code just isn't fast enough to handle the huge number of pixels modern games need to process. If you are someone completely new to using Godot, I recommend that you check out my previous lesson. In that lesson, I have taught how to create a new project. As you can see, I have created a new project. We need a sprite node. Press Ctrl A or click this button. Sprite. Create. For this shader, you can use any texture. For this example, we could use the Godot icon in case you don't have any texture. Just drag and drop this icon onto the texture property. Let's change the location of this sprite. Inside the transform section. For position, type 512 300. Now the sprite is centered. A shader can be added to any canvas item that I note. In this case, a sprite via its material property. Within the material section in material property, select new shader material. Click this box in the shader property, select new shader. Click this box. In this section, we can write shader code. First of all, we need to define the type of shader. Since it will be a 2D render, we will use canvas item. Shader type canvas item. Now, we will define the process of functions so that you take them into account. We will add some comments for each one so that you better assimilate how they work. Void fragment. For the purposes of this example, you'll be coded within the processor function fragment. Therefore, it would not be necessary to add the other functions, but they have been presented since in some future we could use the others. Shader functions have a number of built-ins, which are either input values or output values. For example, the texture input built-in contains the pixel data of the object texture, while the color output built-in is used to set the result of your calculation. The function fragment affects the color of every process pixel. When working with shaders in the texture property, for example, coordinates are measured in a normalized basis, ranging from 0 to 1 coordinate space. This coordinate space is called UV to distinguish it from the XY coordinate space. As a result, all values in coordinate vectors will range from 0 and 1. As a very small example, this first shader will take the pixels of our image and shape them all to a single color. To allow you to choose the color, you can use a uniform variable. Uniforms allow you to pass data into the shader from outside. Declaring a uniform variable will cause it to appear in the inspector, similar to how export works in JavaScript, and also allow you to set it via code. Type the following code into the shader pane. Uniform for As you can see, the image changed immediately. The whole image turns black. To select a different color, within the materials section, select shader pattern. In this place, you will find your uniforms. By clicking on this box, you can choose a different color. In case your image has transparent pixels, consider defining the following line of code. This last line makes the shader output every pixel with the same alpha, i.e. transparency, value as the pixel in the original text. Next, we will define a more interesting code. We will create a blur effect by setting each pixel's color to the average value of the pixels around it. Remove the above code and type the following code. Note that since you added 5 colors values to Godot, the original pixels plus the 4 that are found by moving in each direction around it. You need to divide by 5 to get the average value. The lesson is over. Thank you for completing it. I hope to continue seeing you in future lessons. See you.